All right, let's have some more fun with common ions. So imagine we're trying to dissolve some barium sulfate, and we can dissolve it in one of three different solutions. We can dissolve it in barium nitrate, or sodium sulfate, or sodium nitrate. Pause the video and ask yourself this question: which solution will barium sulfate be more soluble in, and why? Okay, if you've unpaused the video, let's see if we can unpack this. So basically, you might say, well, why does it affect it at all, right? Why does it matter what solution we're in? Well, the barium sulfate, when it's dissolving, we can write down the KSP equation. So we've got the solid dissolving and forming its ions. So barium forms a positive 2 ion. Sulfate is SO4 2 minus. Okay, anytime you've already got these ions present, according to Le Chatelier, it's going to push the equilibrium back, and it's not going to dissolve as much. So if you dissolve it in barium nitrate, nitrates are all incredibly soluble. So essentially you've got a bunch of barium ion already in solution. So if you try and dissolve barium sulfate, this is going to kind of push the equilibrium back, and it's going to be less soluble. Same with sodium sulfate. Sodium, very, very soluble. Sodium sulfate is going to basically be a bunch of sodium and a bunch of sulfate in water. And if you've already got sulfate present, if you try and dissolve barium sulfate, that sulfate is going to act, according to Le Chatelier, and push the equilibrium back, and we're going to find that it's going to be a very low solubility. However, if we look at sodium nitrate, very, very soluble. We'll have sodium ions and nitrate ions. Because those ions aren't in common with barium sulfate, there's nothing over here kind of pushing back the equilibrium, preventing it from dissolving. So the most soluble solution to dissolve barium sulfate in would be the sodium nitrate one. So this section's a little more subtle. So it turns out that pH can affect solubility. And remember, if the pH is low, that means it's going to be acidic. And if we're working in aqueous solutions, that means you've got the H plus ion around. If your pH is high, that means that you are basic, which means that you're going to have not a lot of H plus around, but a lot of OH minus ions around. So consider the solubility of something like magnesium hydroxide. So magnesium hydroxide, okay, it's going to dissolve and it's going to form magnesium ions and hydroxide ions, and it's going to form them in a 1:2 ratio. Okay, remember hydroxide's a polyatomic ion. And what will happen to the solubility as we raise or lower the pH? So how is solubility affected by high versus low pH? Okay, so first of all, it seems like there's got nothing to do with anything here, but of course it actually does. If you're at high pH, what does that mean? That means you're basic. You've got a lot of hydroxide ion present. So at high pH, there's a lot of hydroxide around. It is going to essentially push the equilibrium back because we've got that common ion, and it's going to shift it to the left, so it will be less soluble. So it'll be less soluble at high pH because essentially you've got OH minus in common. All right, now what about low pH? At first glance, it looks like low pH should have no effect whatsoever. The H plus ion, there's nothing in common, right? H plus is not the same as magnesium or hydroxide, so presumably that means it would have no effect at all. Well, not so fast, because H plus and OH minus will react with each other. So when you're under conditions of low pH, okay, the low pH means that you got a lot of H plus around. The H plus is capable of reacting with the hydroxide ion and removing it and turning it into water, right? It essentially neutralizes it. So at low pH, you are going to lower the concentration of OH minus through neutralization. And remember Le Chatelier, right? So if you decrease this concentration, the equilibrium is going to shift to the right to try and increase it. What does that affect the solubility? Well, if it shifts to the right, more of it is dissolving. So it will actually be more soluble in a low pH solution because of this. So this is one of these nifty little tricks. That's why acid rain is such a problem. The acid in the rain, the hydrogen ion in the rain, will react with minerals that contain these basic ions like hydroxide, bicarbonate, or carbonate. You should remember from General Chemistry 1 that all of these ions react with acid, right? So H plus will react with hydroxide, as we've seen, to make water. The H plus ion will react with bicarbonate. Do you remember what it makes? It makes water. and carbon dioxide gas. And of course, the carbon dioxide gas bubbles away, so it can't return to the equilibrium so easily. And if you react it with carbonate, it actually reacts in a 2-to-1 ratio, and it forms the same thing. It forms carbonic acid, which very quickly breaks down to water and CO2. So anytime you've got either hydroxide, bicarbonate, or carbonate in a low pH solution, the H plus ions can react and remove these ions. And if it's on the right-hand side of a solubility expression, if you lower the right-hand side concentration, it will cause a shift from left to right to push more of it over and make more of it dissolve. So solubilities tend to increase. All right, good job.